Okay, let's continue. So I hope all German students from TU Darmstadt can participate. If someone still cannot enter, you can ask Ms. Duyên to accept because she is now the host. But let's explain about the planning relationship between planning area and the depth of planning. So we have the detail of planning, for the depth of planning, and the size of the planning area. Usually we call the study or planning area. And so the bigger the size of the planning area, the less detailed of planning it is. And when the planning area becomes smaller, and then the details become higher. So, for example, the national transport, let's say, the planning area is used is a one nation. So, the detail is not so detailed. It just talk about the demand for passenger movement, the demand for freight movement in the next 10 years by different modes, by airplane, by train, or by railway, by highway, by sea line, or by inland waterway. Then, based on the future demand and based on the current supply of those infrastructure, the study will project how much new road will be need to be constructed, how many airport need to be open, or when to what extent the nation need to expand the capacity for existing airports, and investment plan for constructing the new infrastructure or upgrading existing infrastructure in the next 5 years, next 10 years. However, if we come down to the individual projects such as BRT, Bus Rapid Transit Project, for corridor like BRT, one corridor in Ho Chi Minh City, starting from the West Coast Terminal to the East Coast Terminal, running along the Võ Boulevard. So we have a very detailed, like how many, what is the demand for passenger in the next 10 years, next 5 years, and how many bus need to run every day, and how many bus lane need to be introduced, how to control the signal priority at intersection, right? And what is the ticketing system? What is the terminal? What is station? Where is the station? Yeah. and park and ride for people to access to the BRT station by bicycle, and even it introduced the flyover or road crossing for pedestrian to access to the BRT station, which is located in the middle of the road. Yep. So for the individual projects, it could include traffic calming, reduction of speed measures, parking guidance system, or bus prioritization, and so on, or BRT introduction, and so on. Yeah. So in transport planning, we need to do study, collecting data, analyzing, projecting, and suggesting something, especially infrastructure suggestion, policy suggestion, and other suggestion as well. So, as I explained, for wider area of study, we can have the national or provincial transport planning, which is focused on planning for a large jurisdiction implemented by some transport agency, like by Ministry of Transport or by Department of Transport of Ho Chi Minh City. And it is usually strategic at the strategic level. And the planning is made for a long range, usually for the next 20 years or next 40 years. So we need to look into the future. How to project the future is really a challenging task. Usually we collect the data in the past, let's say for the past 10 years, how population is growing, how land use changing over the past 10 years, how vehicle is growing for the past 10 years, and we project for the next 10 years and next 10 years. That is projecting as a trend. But usually vehicle growing is not linear like this. It's something like a logistic curve. And what is the slope of the curve? It is this one or this one or this one. We have the different option, and the time is to forecast the future based on existing data and experience, including national experience and international experience, and also based on our reasoning ability, our own thinking. Regional transport planning develops plans for a metropolitan region. For example, transport master plan for Ho Chi Minh City. It is made every 5 years. Yeah. So it defines what is the road network in the next 5 years. Also every 10 years, exactly. And what is the railway, urban railway network in the next 10 years, bus network in the next 10 years, how many cars will be used in the next 10 years, and what is the road congestion and how much road need to be constructed, something like this. And or the study can focus on one mode or one specific area. For example, just focus on the bus network. What is the bus network in the next 10 years? So we have to project how many people will use bus in the next 10 years, and what is the bus network and bus fleet and what is a fair policy, fair structure, what is a subsidy need to be provided, and what else, like how to run a much larger bus network, which is integrated in terms of fare system, in terms of information system, right? Like timetable, yeah. So timetable integration of different bus routes allow the passenger to transfer, to reduce the transfer time. So you run from A to B. First, you take the route number 1 and transfer at the station C, and wait for the next the other bus route, right? And we have to coordinate timetable so that passenger can transfer from one bus line to another bus line with the minimum waiting time and with the minimum walking distance. Or we can focus on one area, like focus on the downtown, or focus on this one corridor or one area. Like we are talking about the Ho Chi Minh innovative, interactive, and innovation city in the east part, right? In combining District 2, District 9, and Thủ Đức District. So we study only this area, just part of the metropolitan area. So then we can have some transport improvement plans, as I mentioned, improving the road network in the next 5 years. How many? What is the how to improve the road operation by not only expanding existing road network, but also making signal coordination, optimize the signal program at intersection to reduce the congestion, to increase the intersection capacity, and coordinate signal control along one road, one corridor, so that you can continue moving without stop. Such is called the transport improvement plan. And we have once we have done something, we want to know what is the impact. How much congestion is reduced? How many additional passengers are using new bus service? How many people are shifting from motorcycle to bus to metro? How many people are engaging in using the shared mobility service? We need to do some traffic impact assessment study. Evaluate traffic impacts and mitigation strategy for particularly development. So in this module, you will learn about traffic assessment study in part 5. It's very hectic. Headache. Okay. So I already explained about the concept of planning, transport planning, and the characteristic of transport planning, and different study of different level. Now I'm talking about the conventional transport planning practice. traditional or conventional transport planning. So, as I mentioned, the traditional transport planning is in favor of automobile. It's always think about to reduce congestion by widening the road, and less pay attention to public transport, non-motorized transport, and pay less attention to the environmental issue. So the key principle of conventional planning is to maximize traffic speed, minimize congestion, and reduce distance-based crash rate. So usually it come up with road expansion. And of course, in the conventional transport planning, the transport planner using some well-developed set of engineering, modeling, and financing tools. For example, have you ever heard about the four-step model? Four-step model for demand forecasting and projecting the need for construction of new infrastructure. Never heard, right? So the demand model, let's explain. So the need for travel for one city, it depends on the population, right? Depends on the land uses, right? And usually people move from A to B, from one zone to another zone within the city. So for planning, planner has to divide the city into different zones. For example, Ho Chi Minh City is 300 zones, and each zone corresponds to one word or commune, okay? And we have to project population for one zone or one commune in the next 5 years, the next 10 years. Then we will know, and we will project how many motorcycle ownership rate and car ownership rate in the future. Then we can project how many car trip, how many motorcycle trip will be generated. And based on the distribution of population and land uses at different zones, we can estimate how many car trip, how many motorcycle trip, how many bus trip, how many bicycle trip between zone A and zone B, right? That is we call the four-step model. If you are interested, you can study by your own. But in the last part, in the part 5, we will come back to this. Distance-based crash rate. That means how many crashes per one vehicle kilometer travel. Right. It's just for fatal rate of motorcycle is around 20 to 30 per 1 billion kilometer. So every 1 billion motorcycle kilometer travel or move, there will be around 20 to 30 people die. is called and similarly the crosswise usually is 10 times higher, maybe even 100 times higher. Let's say 2,000 to 3,000 accident per 1 billion vehicle kilometer travel. Okay. So what is the problem with conventional planning practice? As I mentioned, it supports automobile dependency, which is referred to transport and land use patterns, favoring automobile travel over other transportation options. So usually, what they consider is how much is the financial cost to the government if government is going to build new highways network, expanding the highway network. How much vehicle operating cost can be reduced through saving fuel, reducing toll, and reducing tire wear. And how much travel time can be minimized? Yeah. If the new road is built and the commuting time from home to work may be reduced from 1 hour to 40 minutes. And we can make we can aggregate for the whole population under the study area. And per my process, as I already explained, and project construction environmental impact usually is EIA, right? Environmental impact assessment study. That is a traditional planning practice. And what is what issue or aspect is overlooked? Overlooked means is paid less attention, or almost no attention at all. Because they generate the traffic and induce travel impacts. If we widening the road network, reducing the road traffic congestion in the first few years, but people saw that road is better, then they will buy new car and use it more frequently and more car traffic. That is called the generated traffic and induced traffic. It's like if the food is expensive, so you buy just an amount that's enough to eat. But if food is discount, you buy more than you need. That is induced traffic, induced demand. And it doesn't look at the downstream congestion. So improving, constructing the flyover at this intersection to reduce congestion, but it may cause the congestion at the downstream. So you move faster to the next bottleneck, right? Understand? So reduce congestion should not look at one intersection. We need to look at one road corridor or even one area to see what is other solution need to be implemented at the same time. Otherwise, we only solve the local problem, and the local problem is solved and other problem arising. It doesn't look at the impact on the non-motorized travel area effect. The more motorized vehicle, the more difficulty for pedestrian, for bicycle riders, bicyclists, right? They find it very dangerous to cross the road, to navigate, to ride a bicycle and navigate the bicycle at the intersection. It becomes much more difficult and very dangerous. That's why today, all people are using motorcycles to go to school, to pick up children. Parents don't allow children to ride a bicycle to school, even school is nearby. Why? Because it's dangerous. I think because car requires a huge space. Car is require investment in parking structure, building multiple story parking. It costs a lot, especially in the urban area where land prices keep going up. Vehicle ownership and minus space depreciation cost, we never count. When we buy a motorcycle, we never consider the depreciation, right? We only count how much we buy gasoline, how much we pay for parking only. And many others. But as I mentioned, as long as urbanization are taking rapidly, congestion become more severe, environmental issue become more severe, accident become more severe, noise become more severe, and especially local pollutant like the PM 2.5, particulate matters. It's a microfine dust. You never see it. It's clear. It looks like clean, but actually it's not clean at all. It's very, very dusty and very dangerous because every day you are inhaled about 10 cubic meters. You see, every day you inhale, breathe about 10 to 12 cubic meters of air. And within it, many harmful gases, dust inside, emitted by car, by motorcycle, and by other activity like construction. So we have to solve all these challenges to make sure that we move around the city in a safer manner, in a greener manner, a reliable manner, and saving energy. And will not sacrifice the need of our young generation. And that means we have to change we have to use the different options for transportation. Not only purely focusing on car and motorcycle. We need to think about the bus, the metro, bicycle, and walking, cycling, and others, and even water bus. Yeah, water bus also good means of transport. So, transport planning in recent years, especially in developed cities, have put the emphasis on non-automobile modes like bus, metro, bicycle, and give due consideration on environmental impacts and mobility for non-drivers or mobility for all, especially women, girls, children, elderly. Elderly cannot drive. They cannot drive. They have to rely on public transport, transit system. And that means we are now increasing the portion of fund or financing for other transport modes. And you know, when the transport system becomes more complicated, more system, more vehicles, more time, more option of transport, that means when we do the planning, it becomes much more complicated, right? The interaction, the dynamics becomes complicated. How to project the future, how to do the impact study, it becomes more difficult. But don't worry, we have the data, even we have the big data, right? Increasingly, we are getting the big data for analysis, forecast, and making optimized planning. So we are now improving chatbot modeling technique. Okay, as I mentioned, we need to focus on multimodal mobility, not only a single mode mobility. And multimodal mobility means 2 or more different modes are used for a single trip between which the traveler has to make a transfer. So going from home to work by car is bimodal. I'm sorry. It's a single mode. Or going by bus service only. Of course, we have to go to bus stop and then from the last bus stop back to office. This is also a single mode mobility. But in this case, first we walk to bus stop and take the bus and go to the railway station and transfer from bus to train and going to work, and at the last bus stop, the last train station, we walk to the office. This is called multimodal because the traveler has to use 2 modes, first bus and second train or metro. So what does it mean in terms of the distance and the time or cost? In case of a single mode mobility, here is car, so directly from the starting to the ending point, right? But in the case of multimodal mobility, first the person has to take a bus, and then, this guy is the bicycle, it's not true. It's not corresponding. I'm sorry. Let's say here is a bicycle. First, the person drive bicycle to train station and park bicycle there and wait for the train. That means no distance moving, but takes time. And train come and go to the bus station and walk to the office. So time could be shorter, total time could be shorter, or travel cost could be lower. But it may be the transfer, maybe a barrier. This could be longer if train frequency is low, or if no parking for bicycle at station. Where should I park my bike? Okay. Now, when we talk about multimodal mobility, in order to offer multimodal mobility service, we have to make planning. And multimodal planning refers to planning that consider the various modes, including walking, cycling, automobile, public transport, and so on, and connection among those modes. That is the multimodal planning. But multimodal without good connection, without good integration, is not good. It cannot attract people to use it. As I mentioned, if there is no parking for bicycle at the railway station, people are not willing to ride bicycle to the railway station, right? So we have to make an integration between both. So that we integrated multimodal transport planning refer to transport and land use planning that consider diverse transport options, including walking, cycling, bus transit, automobile, and accounts for land use factors that affect accessibility. This is important. Accessibility and land use factors need to be accounted, need to be considered. So in this case, not only offering bus network, expanding the bus network, offering the bicycle lane and sidewalk, but also bringing housing and office closer to the railway station is important because people can walk short distance to railway station, can ride a bicycle fast to railway station. Yeah. Or after getting off the train, they can immediately walk to office. So that means the first mile mobility service and the last mile mobility service become equally important as the main road. Yeah. That is the difference. Before, we always think about improving bus network, expanding bus network, buy a new bus, but never consider improving working condition, introducing park and ride system, right? That's not good at all. Now, what is the difference between automobile dependency versus multimodal transport system? This table is showing the comparison in terms of different factors: vehicle ownership, vehicle travel, land density, land mix, land for transport, road design, street scale, traffic speed, walking signage, parking, site design, planning practices, and social. Difference between automobile-oriented planning and multimodal transportation planning are different. For example, you are urban planner, so I'm talking about land use. Land density, in the case of automobile dependency, it is low, and the common destinations are dispersed, as I already explained. Yeah. But in the case of multimodal transportation, the land use density is medium. That means higher, and destinations are clustered. Bring closer, bringing them destination closer. That is the difference. And land for transport. In the case of automobile, huge amount of land devoted to road construction and parking construction. But in the case of multimodal transportation, medium amount, that means less land devoted to roads and parking. Because the demand for car use become less. And what else important but difference? Social expectation. In automobile dependency case, non-driver like pedestrians, cyclists are stigmatized. That means no attention or very less attention. Planners say something about improving working conditions, but actually it doesn't. But in this case, non-driver are not stigmatized. That means significantly considered, and the consideration increasing over the time. What do you think the benefit of integrating different modes of transport? At first, we can enhance the system efficiency of the transport system. Yeah. Please imagine that we have the existing bus network, but working condition is very poor. So the ridership or the number of passengers is low because people hesitating to use bus because walking is so awful. awful, not awesome, awful. But once we improve the working condition and providing park and ride for bicycle, then more and more people use bus. That means we can increase efficiency of existing bus. And people work more and become stronger, healthier. This one will become smaller. Okay. Then therefore we can reduce the road congestion, we can reduce air pollution, we can improve affordability, affordability for low-income user. Yeah. Low-income user don't need to spend a lot of money, saving a lot of money to buy a car. They can use transit with a low cost. Enhance social cohesion. Everybody ride a car, no talk each other. If they talk, they say ping, 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 ping. But when people getting in a bus, they can sitting nearby, we can talk each other, and when we walk, we can interact with the environment and the other people easily, right? If I ride a motorcycle and you ride a motorcycle, and when we see, say hello, hi, and just pass by. But if we walk, we can stop for a few seconds for exchanging information. Okay, that is more social cohesion. And then social equality. When we talk about equality, it's really important. So if the high-income people and low-income people can ride the same transport system, that is bring the fairly social equality. In Japan, CEO and white-collar workers riding the same train, sitting on the same seat row. No need to ride a fancy car. Everybody use train. And we integrate different modes, we can have a new financing opportunity. I will explain later. Why is a new opportunity for financing? Yeah, that when we focus on public transport and non-motorized transport, at least a proportion of funding is diverted to transit. It's open a new funding. Yeah. Okay. 10 minutes more. 10 minutes more. And then we will have a break and the last session. I think today we can go as long as we can. Yeah? And tomorrow we may shorten our lecture. I think the last part is more interesting to you because it's about the TOD, transit-oriented development. It's perfectly fit to your interest. Now, what is the mechanism for the integration of different or various transport systems or modes? We have a different layer for the integration. At the functional level, is integration between transport function and land use function, land function. Where we get on the train is also where we can do banking. We can draw money. Where we get on the train, we can do shopping because supermarket is located inside the station. Where we get on the train, we can have restaurant. We can have dinner with friends, we can have a coffee with friends because Starbucks and Highland Coffee is located there. And where we get out the train is also where we meet each other for business, for scientific conference, because some conference hall is located just next to the railway station. That means we mix different function, mobility function and land use function together at one place, one destination. Okay, or this is the road, this is intersection. Here is the bus stop, and here we have the park and ride lot, and here we have the informal transit parking, we have the bicycle parking, we have so on. So that means we can integrate different modes at one place. This is simple, but this is really integration between land use or land function and the mobility function. Yeah. This showing the station development area. Here is the station, and after getting off the station, you can go to the housing, to a spot or stadium or park and others very quickly and easily. Now, after the functional integration, we should have the physical integration. That means the network integration. Integration between the bus network and the railway network, integration between bicycle network and the bus network. Yeah. So it means the smaller hard infrastructure integration, which is allow for easy access and interchanges between different modes, such as building stations that service multiple types of transport. Like here, this is an airport. So right after the airport, inside the airport we have the bus station. Yeah, and we have the car park. So after getting off the airplane and checking out, you can ride a bus home or to the final destination. And here at the train station, you can have the bus stop station. That means after getting off the train, you can get on the bus, or after get off the bus, you can get on the train immediately. And this integration is usually easy to take place because it's engineering. Just engineering issue. And this is some other conceptual concept of public transport integration at railway station. So you can see here the railway station, and it has two sides. And inside the railway station, it has a commercial establishment, shopping malls, coffee shop, everything inside the railway station. And at four corners of the railway station, we have the bicycle stand, bicycle sharing, we have the subway and metro station just nearby, and the bus stop just in front of the railway station, and we have the paratransit where we can use the jeepney or tricycle or something else. So this is the concept, and this concept is well known and practiced everywhere. And now not only integration at the node or at the station, but integration in terms of network. Because here is non-stop railway network and tram and buses. So we can see that the tram and the railway as a backbone, and the buses is supplying, complementing and making a really dense network. So allow people to access to the transit station everywhere, just within 200 meter walking. They can get to bus stop or train station or the tram station and so on. That is very convenient. Yeah. Next one. Not only is physical integration, network integration, but also operation integration. Operation integration usually referring to integration of ticketing system using the same common tickets to use train, bus, tram, or even bicycle sharing and so on. Integration also in terms of the timetable, allowing passenger to transfer from one system to another quicker. When I remember when I stay in Tokyo, I get off one train and get into another train just within 20 seconds. So this train is arriving, stop, and I get off, and at the other platform, just nearby, the other train is already also arriving. So I get on the train, just within 20 seconds. If it's longer, I may miss the train. So that means the railway operator has to synchronize timetable of different train line. And even I have to choose which car I should stand, middle or at the end, or at the beginning or at the end, because that will determine whether I can catch the next train or not. Because other train may be at different level, right? At different level, and only if the escalator is only at two ends, that means I have to stand on the car at the two ends. If I stand in the middle, I have to walk longer distance. But anyway, fortunately, we have innovation in terms of technology. Technology allows people to check information and make perfect schedule. So, like in Japan, I can use app to check what train should I take and what time it will arriving, and what vehicle or what car should I stand in order to transfer faster. Everything is on mobile phone. But it's simple for user, but it's not simple for provider. And very complicated. And a lot of time is institutional integration. It may take years and years or never happen. But this is most critical. This is if the train operator and the bus operator don't shake hands and no integration. If urban planning and architecture department and transport department don't shake hands, land use and transport integration never happen. Okay. Whatever the good ideas, but key stakeholders don't work together or don't integrate, merging, then ideas is just idea. As I mentioned to you, in terms of planning or whatever other technical aspect sector, we have the different stakeholder in the planning process and even the management process. National government regulating law, through law and regulation. Regional and local government have specific policy, rules and regulation. And public service provider like a bus operator, train operator, yeah. And the private service providers like a business, they have to consider business model, and citizen, customer and user, they have their own preference, they have their own norms, own attitudes and habits. If people are not don't understand the need for prioritizing bus system, every time government propose to introduce a bus lane, under the circumstance that road is already congested, right? People start crying. Why road is already congested? Why you take one lane out of three and making the road is much more congested? We cannot stand. We cannot understand. We cannot accept. But people always asking, please improve the bus service. Please improve the bus service, then I will shift to use bus. But once the government introduces a bus lane to improve the bus service, improving the speed, improving the reliability, people start crying. So this is usually it takes time and very complicated. Yeah. Even for developed cities, countries, it takes years and years. Okay, so short break. We will come back here in 15 minutes. That means we will start from 10 past 4. 10 past 4.